Hey guys, welcome to another episode on my channel. So in today's episode we are going to talk about deep sleep mode with ESP32 microcontroller. And this feature you are not going to use too often except in cases when you need portable systems. So in cases when you have some regular power supply to attach to your microcontroller, you don't have to worry. But in situations when you have to use batteries with your microcontrollers, well, consumption is a serious problem. And how actually deep sleep mode solves all of that? Well, in deep sleep mode, your microcontroller consumes between 10 and 150 microamps, which is excellent for this purpose. And finally, how to implement this solution. You are going to throw your microcontroller in deep sleep mode whenever it doesn't need to be active. For example, you have some sensor attached to it that is going to be used from time to time. You want to be able to activate it whenever you need it. But in the rest of time, you need to preserve your battery. So in this episode, I'm going to show you how to enter deep sleep mode and how to get out of it. And there are actually multiple ways to do that. And for this episode, I'm going to show you 4 of them. First, we are going to wake our microcontroller with timer. Second way, it's with touch signal. And third way, it's external impulse. Well, timer is the simplest of all. You just need to set time when you want your microcontroller to wake up. Touch signal, it's also self-explanatory. Whenever you deal with that particular pin that is considered to be touch pin, your microcontroller is going to wake up. And finally, I'm going to show you how to wake up your microcontroller with external signals. Well, touch signal is also external signal, but in this case, we are just going to set some pins to high or to low in order to wake up our microcontroller. And we actually have 2 functions for that. And now, why do we need these jumping wires and these 2 10K resistors? Because electronics of our microcontroller, it's extremely sensitive and you can easily find some leftover charge that is going to mess your readings. For that reason, we are going to use these resistors to pull our signal down. And don't worry, in this episode I'm going to show you exactly how to do that. And now just connect your microcontroller to your computer and we are going to start coding. So guys, before start coding, I have to explain you one additional thing. You have to check documentation for your microcontroller's board, and particularly pinout. Because with external wake up method, we can use only RTC pins. And with touch wake up methods, we could use only pins that are considered to be touch pins. You cannot use just any general input-output pin for it. So for this episode example, I am going to use my pins 32 and 33 from my ESP32 microcontroller. These 2 pins are both touch pins and RTC pins. So I can use both methods. And another thing, if you want to use variables, your variables must be RTC variables in order to use them with deep sleep. So if you want to preserve some values through deep sleep, that value must be labeled as RTC value. And how to do that? I am going to use RTC underscore data ATTR. And now I'm going to provide variable type, so integer, and it's going to be counter. And I'm going to set it to 0. So now this value is going to be preserved through deep sleep. And now I'm going to create one support function. That function is just going to print a reason why our microcontroller is activated. So I'm going to create a void wake up reason. Okay, we don't need any arguments. So first I'm going to create one variable, ESP sleep wake up cause T and call it reason. Now I'm going to say that reason it's ESP sleep underscore get wake up cause. And now we are going to use switch. We are going to check for reason. And for example, if reason it's ESP sleep wake up, let's find timer. So I'm just going to print something to my screen. Timer. is the reason. Okay, and break. Now if case is ESP sleep wake up touchpad serial println touch is the reason. Of course break, then case ESP sleep wake up external 0. It's external signal type RTC IO. Of course break, we need one more, and I'm just going to copy this, it's much easier. So it's external 1, and in here we are just going to change this type CNTL RTC underscore CNTL. Don't worry, I'm going to explain everything in details. Now I'm going to remove this unnecessary empty space, and we are going to deal with void setup. In here, of course, first thing, I'm going to initialize my serial monitor with baud rate of 9600. And every time when you wake up from deep sleep, you are going to run this method again. So first thing that we are going to do, we are going to raise our counter by 1. Counter plus equals 1. Now we are going to print value of our counter. Serial print F. Counter value it's %d, and I'm going to provide my counter. So whenever we wake up from deep sleep, whatever reason is, this value is going to be bigger by 1. And second thing, we are going to print wake up reason. So we are going to use this very same function, wake up reason, in order to print that. Now, first method that we are going to use, it's a wake up by timer. So what we need to do first, we are going to use ESP sleep, not EPS, sorry, ESP underscore sleep underscore enable. And what we are going to provide to this function as argument, we are going to provide a number in microseconds for how long we want our microcontroller to be in deep sleep. And I'm going to provide something like 5 millions. That means, no, sorry, I have 1 0 more than necessary. So we are going to wait. So when we enter deep sleep, we are going to wait for 5 seconds before our microcontroller get activated. Okay, after this part, I'm going to initialize deep sleep. So not EPS, ESP deep sleep start. It's this function. Oh, okay. And one other thing, what I want to do, I want to flash my serial monitor before we enter deep sleep. Now I'm going to build this code. Okay, upload. All right, and now I'm going to open my serial monitor. You see? We are just badly formatted this printout, but you can see that counter is 3, timer is the reason. Counter is 4, timer is the reason. Counter is 5, timer is the reason. So this code works. Okay, let's go to another method. Just I want to add a new line after value of our counter. And up here we have new line with function println, so that's completely fine. So Now I'm going to comment this code, so we are not going to use a timer for our second method. We are going to use touch. So you are going to activate touch with ESP underscore sleep enable. Where is the touchpad wake up? And now I'm going to create additional variable, touch pad t, call it touch. Now touch is going to be ESP sleep underscore get touchpad wake up status. So this function is going to return actual pin that we are going to use in order to wake up our microcontroller, and I'm going to print this to my serial monitor. Serial print ln with pin %d new line, and I'm going to provide touch. Not ln, but print f. Okay. But now with this touch, what else we have to do? We have to call function touch sleep wake up enable, and in here a first argument, it's actual pin that we are going to use in order to wake up. GPIO num 33. I'm going to use this pin, and in here we have to provide threshold. I found that with my microcontroller, best result I'm getting with 100. With different boards you are going to get different results, so in order to know what you are doing, please check your documentation. So now I'm going to save this code, I'm going to build it again, and I'm going to upload it to my microcontroller. Okay, now in the corner you can see my microcontroller with wire connected to pin 33, and now I'm going to start my serial monitor. Let me see what we can find in here. I'm going to restart my microcontroller. Okay, now whenever I touch this wire, we are going to wake up our microcontroller. Check this out. As long as I'm holding to it, we are keeping with restart. All right. And now I'm going to show you how to attach callback function to this method. So now, in order to attach interrupt to your touch method, what you should do? Change this touch call to touch attach interrupt, and in here we are just going to add another argument that is callback function. Call it callback. I'm going to change threshold to 20, and I'm going to create that function in here. Void callback. So what I want to do now, I want to raise value of our counter by 20. Of course, I'm just going to build this code and I'm going to upload it. All right, I'm going to open my serial monitor. And now when I touch this pin, what we are going to get? Touch is the reason, touch activated with pin 8, value 23. Touch is the reason, touch activated with pin 8, counter value 44. All right, let's try it again. Okay, and we arrived at value 171. So this method works. All right. Okay, I'm going to comment this function call. So now what we are going to do, we are going to use ESP sleep enable ext0 wake up. Okay, and in here first argument is going to be pin that we are going to use to wake up, and of course this needs to be RST pin. So I'm going to call GPIO underscore num33, and I'm going to use a high for second argument. So whenever we receive high signal on pin 33, we are going to wake up. And for this method, we are not going to need any of these 4 lines. Okay, I'm going to save it, build it, and upload it. So now I'm going to restart my microcontroller once again. I'm going to open serial monitor. So now you can see that I have used these resistors to pull my pin down in order to prevent false readings. So now what I'm going to do, I'm going to use this pin to connect to my 3.3 volts, so to provide high signal to my pin 33. You see? Let's do it again. So as long we have high on pin 33, we are getting result. All right, so this method also works. So let us try our final method. So first I'm just going to close all of this, and now instead of using ext0, we are going to use ext1 wake up. But with this function we have to provide different arguments. So we are going to provide basically a list of pins that we are going to use. So for this example I'm going to use pin 33 and pin 32, but we have to provide those numbers in special way. So I'm going to open my calculator, and in here, in order to get a mask for your pin, what you have to do, you have to use base number 2, and then you have to calculate that number to power of number of your pin. So if I want to use pin 32, I want to provide number 2 on the power of 32. And if I want to use additional pin, I have to sum that number with same calculation. So if I want to use pin 33, I have to count 2 on the power of 33. And now I have to calculate that. So this is number that we want. But not only that, we want hexadecimal representation of this number. So I'm going to choose programming type of my calculator, and I'm going to get this value from hexadecimal. I'm going to copy this number and I'm going to paste it as first method. So 0x and number we have just calculated. And as second argument, we are going to provide ESP ext1 wake up any high. So whichever of these 2 pins receive signal high, we are going to use that as reason to wake up. I'm going to save this code, I'm going to build this code, and of course I'm going to upload it. So now you can see that I pull down both of my pins, and I'm going to restart this microcontroller, and I'm going to open my serial monitor. Let's see what we are going to get. First I'm going to try with this green wire to 3.3 volts. Alright, we are getting result, and now I'm going to try with this another pin with 3.3 volts, and we are also getting our result. Alright. So guys, that's all for this episode. I hope that you learned something new and something interesting, so please like, subscribe, and see ya!